This Week in Virology, the podcast about viruses, the kind that make you sick. From Microbe TV, this is TWiV, This Week in Virology, episode 1129, recorded on July 5th, 2024. I'm Vincent Racaniello, and you're listening to the podcast all about viruses. Joining me today from Western Massachusetts, Alan Dove.
Good to be here. And it's yucky weather here. It's 85 Fahrenheit, but 29 C. The dew point is 74 Fahrenheit, 23 C. So it's just really, really sticky outside.
Yeah, here in New Jersey, it is 31 C. Very humid. I don't see any humidity reading here on my thingy.
Yeah, relative humidity 70% here.
Yeah, 69% here. Feels like 36 C.
Yeah.
Rained last night and it didn't put a dent in the
No, it just made it wetter.
So it's you and me, Alan.
Just us. We haven't done one like this in a while.
I think in the early days.
In the early days, Dixon would be off fly fishing or something. And
well, if you recall, I had Dixon on originally, and then after a while, he said, "I'm going to India for a month."
Yes.
So that's when you joined, and you and I did some episodes together. But this is what happens during the summer, I suppose. Nevertheless, we shall give you your virology as usual. Speaking of virology, if you enjoy these programs, consider supporting us. Microbe TV, which is the production company that does all these podcasts, not just TWiV, but all the others. They're a 501c3, a tax-free entity in the U.S., which means your deductions are federal U.S. tax deductible. Microbe.tv/contribute. We have some news summaries today, courtesy of Amy Rosenfeld. The first is measles in Kenya. And the link is to a WHO weekly bulletin on outbreaks. It's very interesting. It's a nice document. And it has a map of Africa there with all kinds of things going on. And this is all about measles. So you can scroll down to the measles entry. This outbreak has been ongoing since December of 2023. There have been over 1,500 cases and 11 deaths.
Yeah.
Most of the cases under 5-year-old. And, this is mainly in unvaccinated people. Only 6% of the cases are in people who've got 2 doses of vaccine. So this is not good. You have to immunize.
Yeah. Yeah. And, I suspect that the vaccination problem in Kenya is a bit different from the vaccination problem in the U.S. It's not so much that people don't want to get it, but maybe they can't.
I think so, yeah.
Lack of access, especially in remote areas.
There's a map of Kenya here where you can see where most of the cases are. Very nice document.
Yeah.
And then there are other things going on in the world which are part of this document as well. Next, we have a trial for a nasal COVID-19 vaccine. This is the NIH news site. NIH-sponsored trial of nasal COVID vaccine opens. So this is a nasal vaccine. It's sprayed in your nose. And let's see what it actually is. So it's going to enroll 60 people. So this is a phase 1 safety profiling. 3 cohorts. The first will get 1 dose. And the next 2 will get higher doses.
Pseudotyped murine pneumonia virus.
Ooh, look at that. Murine pneumonia virus is a vector to deliver the spike protein. Interesting. Murine pneumonia virus does not cause disease in people, but does get into epithelial cells in the respiratory tract. In preclinical non-human primate studies, it was safe, well tolerated. It produced good immune responses, systemic immune responses, as well as local immunity.
Yeah, cool. This is a neat idea. And I think this would actually also go a long way toward cutting down vaccine hesitancy of a lot of people because people come up with objections to vaccines, but often when you get right down to it, it's about being afraid of needles.
Marine pneumonia virus is a murine homologue of respiratory syncytial virus.
Okay.
But uh, Alan, people are going to say, I'm not putting no stinking mouse virus into me.
But okay, there are some people who you will never, ever convince, but I suspect that there are a lot of people who are hesitant about COVID-19 shot because it's a needle, and if you're getting the mRNA vaccine, my own experience and that of many other people is that it's a little harsher ride than a lot of other vaccines. So this might be an easier option.
And one of the states where people don't like to get vaccinated is Florida.
Yeah.
And speaking of Florida, there's a dengue outbreak in Florida. 2 cases of locally acquired dengue fever. So that means these people were bitten by mosquitoes in Florida, not somewhere else. And they acquired the virus from those mosquitoes who got it from another person who was infected,
Yep.
locally transmitted.
Now, a lot of dengue is asymptomatic or minimally symptomatic. So if there are 2 locally transmitted cases, I think it's a safe bet that this is transmitting a little more widely than that.
Oh, there's posters here too on this document.
Yeah.
Mosquitos pueden propagar enfermedades.
Hmm.
Do you speak Spanish,
Yeah,
Alan?
I do. Not very well, but
No deje
yeah.
que se reproduzcan los mosquitos. I love it.
Yeah.
Nice
Yeah.
informational
Get rid of
poster.
the egg laying sites, empty out the water from your containers that might be outside.
Yeah, like your tires. If you got tires in your
Got
backyard.
tires. The thing that they mention so seldom in these that I think is probably kind of important is make sure your gutters are not clogged
Mm,
because that'll pool water right up above your backyard, and then the
for sure.
mosquitoes just have to drop down on.
But just a bottle
Well,
cap, throwing a
but
bottle
any
cap on the
yeah,
ground.
the mosquitoes for dengue, we're dealing with mosquitoes that are container breeders, and it's any kind of container, flower pots, that kind of thing.
So, yeah, be careful of the mosquitoes. Yeah.
Yeah. And I have a related story that I also linked. NPR just did a piece in their shots column
Hmm.
on how it's a big year for dengue in Central and South America, which is consistent with what's now spreading in Florida. Of course, it's a lot more widespread in Central and South America, but there's a lot of travel between these places. And so um, we should be on the lookout for it, not only in Florida, but across the U.S. South.
1,500 cases in Puerto Rico.
Yeah.
Wow. Where it's endemic. So they're all locally acquired,
Which is
continuously
right, not just
circulating.
Central and South America, but also the southern portions of North America, which the
Yeah.
Caribbean is part of North America.
Interesting.
Yeah.
All right. And finally, interesting article in Science. Scarred by COVID-19 experience, Spain launches new office for scientific advice. Body will coordinate a network of science advisors throughout the Spanish government and oversee expert advice in times of crisis. That's not a bad idea.
When do we move?
Spain is not a bad place to live, right?
No, no, it's a beautiful, beautiful country.
The only problem is they eat kind of late.
Yeah, I could adapt. Yeah,
What-
this is a very, very good idea. And nice to see a country actually learning from the pandemic and saying, gosh, it would have been nice if we could have coordinated our scientific response a little better, and they're working on it. I am very impressed.
They say will establish a network of advisors across government departments. They decided to create the body after finding very few scientists to turn to for advice during the COVID pandemic. Same thing here,
Yeah.
but we're not going to do such a thing,
No,
right?
we're not going to do. Now, the important thing with this is as I say, I think this is a very positive development. The key is going to be how long they're able to maintain this in the absence of future pandemics. I mean, it could be 10 years before the next pandemic, and that could be a few administration changes in Spain, and maybe people say, yeah, we don't need to keep budgeting for this, which is kind of the fate of a lot of public health stuff.
Yeah. Unfortunately, they could have listened to TWiV also,
Well, true.
but do we understand it's not their native language? Yeah, we'll see how this works. I'm really curious
Yeah.
because the thing is, you got to pick the right people, right?
Yes.
So if we did this in the U.S., they would pick Robert Redfield to be on it, which would be useless.
Well, it depends on who's in charge in the US when they put this together.
Hmm.
There are a lot of good scientists here who could go on something like this. We do have organizations that can kind of fill this niche. Unfortunately, the lead organization that we have for pandemics at the time of the COVID-19 pandemic was, in fact, led by Redfield, who was answering directly to Trump. And so the CDC was not really on board. They were just asleep at the stick.
Good luck, Spain.
Yeah, yeah. Good idea.
Okay. On to the literature. We have 2 papers for you today. The first has to do with long COVID. We try to do a little bit of basic science here to try and understand what's going on. This was actually covered by Daniel Griffin in his weekly update yesterday, but we'll do a little deeper dive. Science Translational Medicine, tissue-based T-cell activation and viral RNA persist for up to 2 years after SARS-CoV-2 infection.
And I can
Daniel,
do, yeah, yeah.
did,
I'm just going to run through
go
authors
ahead.
and
Yeah.
affiliations. So we have 3 co-first authors: Michael Peluso, Dylan Ryder, and Robert Flavel, and 2 co-senior authors: Henry Van Brocklin and Timothy Heinrich. A large team in between those. And this is an entirely San Francisco-based team. I think last week we had an entirely Boston-based team. So everybody here is from San Francisco. Most of them are at UCSF, and then there are 1 or 2 people from Cell Site Technologies.
So as everyone has heard multiple times, long COVID is a set of symptoms that persist after acute SARS-CoV-2 infection, unexplained system. CDC estimates 15% of American adults have experienced long COVID, and 6% are currently experiencing it. 18 million adults. That's a lot of people,
That is a lot of people.
and in particular, there are no treatments. So it would be really important to understand it, and so you could develop treatments. And this paper tries to get at it in an unusual way. I'm not sure they have a definitive answer, but it's an attempt.
It's a new tactic. I didn't even know you could do this.
Yes, I didn't either.
I mean, I've certainly been aware of PET scans, PET CT scans, but yeah. Anyway, we're going to get into it. It's really, really cool.
So as you know, COVID-19 is highly inflammatory, and we think a lot of these long-term effects um, have to do with the inflammation. But it, it's hard to sample most tissues except blood. Most of the sampling is done with the blood, which likely doesn't give you the whole picture. As they point out, it's hard to, in a healthy person, to sample brain, spinal cord, heart, etc. There's something you could sample the gut, which they do in this paper, but even the lung, right? If you want to get way down into the lung, is hard to sample.
Yeah, and a lot of these, yes, you can sample the gut with a fecal sample. Most people don't mind giving that up. But if you want to consent somebody to take a biopsy of their gut, then that's a little bigger request.
Yes, it's a big ask, as we would
Yeah.
say.
Yes.
So they do whole body PET imaging, whole body positron emission tomography, and PET is a modality that was developed to look for cancer sites of cancers in people. They typically give you a radioactive glucose, and then they do an imaging like a CAT scan, and they see cancer cells tend to take up um, more of the label than other cells, and so you can look at metastases and so forth. The modification here is they use a different label, a fluorine ARA G, which was developed to specifically label T cells for people with T cell malignancies. It's quite interesting. It's actually also a chemotherapy agent. It gets into T cells um, preferentially, but it can also be used for the imaging, and it's been approved by the FDA
Yeah.
to do this.
And what's so cool here is I would think if somebody said we're gonna label the T cells, you just gonna light everything up. They're all over the place. What are you gonna be able to see? But the resolution on this is high enough. You can actually track, where more of them are and where fewer of them are.
Yeah, so more and brighter, right?
Yeah.
So the people involved here, there are 24 participants. This is from University of California, San Francisco. Two groups of people. So 24, it's not a lot, right? But I mean, this is expensive modality. A PET scan is not cheap. 24 people, two groups. One group in the early post-acute phase, so less than 90 days from your COVID, and these are people with and without complete recovery.
And
So
by the way, in terms of the 24 people I just counted, I think there are 50% more authors than there are subjects in this
yeah,
paper.
a lot of data interpretation. Yeah.
Yes. Anyway, continuing.
And then they have a second set um, who are later in the later post-acute phase, over 90 days with and without complete recovery. I mean, the numbers dwindle, right? Because we only have 24. And then in these two groups, we have 3 and 6 in the non-recovered and recovered. And then we have 3 and 12 in the recovered and non-recovered. Now, the problem here, in my view, their controls are pre-pandemic scans that had already been done of people, healthy people before the pandemic, right? And they say, we decided to do this because there's a lot of asymptomatic COVID and so forth, but I think that's important to know, right?
Yes, I would have liked to see not exactly, well, I guess positive control would be the term for it. So people who have lived through the pandemic and probably got infected but didn't have any bad sequelae from it, and
Yeah.
um, might be
Yes.
nice to add to
Because
this.
as you will see, we're going to find T cell activation. We're going to find remnants of viral RNA. I don't know if that's specific for long COVID or does it happen in people without long COVID. You can't even tell from the study here where they have some patients who don't have long COVID. You can't really tell. And I think that's a key issue. I mean, they're clearly different from the pre-pandemic samples, right?
Yes.
But I don't think that's the relevant sample because I bet
Well,
today,
it's
if you did 100 GI biopsies, you'd find a lot of SARS-CoV-2 RNA in people.
yeah. Yeah, and I think it is. I think the pre-pandemic controls are a relevant control. I don't think they're totally irrelevant. It's nice. I mean, it's a beautiful bit of luck that they happen
Yes.
to have done these before the pandemic. And yeah, look at those data. But I would, and they're forthright about this in the discussion. They say, a major limitation is the small number of patients we've got, and we'd love to be able to do this on a larger scale.
Yeah, I agree they're not totally irrelevant, but I don't think they they totally support their
Right?
idea. But
No,
they
I
actually admit
I
it. They
agree.
say
Yeah.
this actually doesn't prove anything. We need bigger
Right. Yes.
studies, right? In the end. The most common symptoms, by the way, fatigue, 16 of the 24, and neurocognitive complaints, 14. And 6 people didn't have any symptoms, but as far as I can tell, they're not much different from in terms of the assays they do from the people with long COVID. So that's kind of a problem. Okay, so they use this F18 ARA G. It's an imaging agent, as I said, originally designed to assess T cell activation, and it's FDA approved for chemotherapy to treat refractory T cell malignancies. It's highly selective for activated T cells in people, right? So they infuse this into people intravenously, and then they do a PET scan. Actually, it's a combined PET. Um, for the pre-pandemic, it was PET MRI, and I think here they do PET
Pet CT, I think.
CT. at the same time, and then you get these whole body images, which you can see here, which are kind of creepy, right? You can see people's
Yeah.
faces and hands and everything.
Yes. And
Um,
this is, unfortunately, this is closed, this is paywalled, I think. So
yes,
many listeners won't be able to see the images, but
and then they take these images and they basically circle areas that look interesting, and they subject them to image analysis, digital image analysis, so they can see. They can measure maximum values of the uptake, right? Because the drug is radioactive, so it will be dark on the image, and they can measure the intensity and the mean values and so forth in the areas of interest, as they call them. So higher uptake, we'll call it uptake, were observed across a variety of anatomic regions: lymphoid tissues, glandular tissues, vascular, spinal cord, in these post-acute COVID participants compared with pre-pandemic controls. Now, if you just look at the figures, it's hard to see that. I mean,
you need software to figure this
you
out, I
need software,
think.
man, because you look at that. There's two pre-pandemic controls in figure two, and the intestines are lighter than in the others, right? You can see more intestinal stuff. But the two pre-pandemic controls differ. I think one of them, the bladder is lighting up, and the other it's not, right?
Right.
And that's the same thing with post-COVID. So I think there's a lot of variation. We're not we don't not expecting that's expected to have patient-to-patient variations, right? And so they describe all of these things that are different. So then they do this over a course of 2.5 years, right? So they want to measure T cell activation, how long it lasts. And again, they look at the different tissues of interest. And uh, in some tissues, it goes down modestly, like thoracic and lumbar spinal cord, colon, rectal wall, blah, blah, blah. But most of the time, it doesn't change very much over the 2.5 years. So this is a persisting change compared to pre pandemic control. They tried to Now they tried to see if they could make associations between T cell activation, right? The T cell activation is measured by dye uptake and
Right.
long COVID symptoms. So they did this for people with symptoms, that's 18, and people without symptoms. Okay. So they say tracer uptake in many tissue regions was significantly higher in post acute participants with and without symptoms compared with pre pandemic controls. So you see,
Yes.
the people who don't have any symptoms also have
Also have this.
this
Yeah.
dye uptake going on. So that's the problem. And there are a couple of sites.
I guess we all died a little bit in the pandemic.
Yeah, indeed. Indeed. There are a couple of sites where the uptake was higher in the only in people with long COVID compared to the pre-pandemic controls. Okay. So that's the right helium, the colon wall, and the rectal wall. So those seem to be higher in the people with symptoms compared with those without, with respect to the pre-pandemic. But they say no statistically significant correlations were observed between the number of long COVID symptoms and uptake anywhere. Okay. Then they ask whether specific symptom phenotypes correlate with uptake in different tissue. And the only place they really see a difference is in the lung, the lower lung, where people who have long COVID lung symptoms, pulmonary symptoms, cough, shortness of breath, dyspnea, they have elevated uptake down there. Okay. Um, but everywhere else, the heart area, the brain, the CNS, no correlation between
Right.
symptoms and dye uptake. They also looked at the effect of vaccination. No effect of vaccination on dye uptake, which is interesting because a couple of studies have now showed that vaccination can decrease long COVID incidence. It's not
Right.
huge, but there is an effect, but that's not reflected here. They also looked for a correlation with antibodies to the nucleocapsid protein. to try and see if recent infections make any difference and no difference. Among the post-acute COVID group, the presence of a detectable nucleocapsid response, antibody response, did not have a major influence on dye uptake. They also looked to see if there was a correlation between the dye uptake and systemic immune activation. They assess different protein mediators of inflammation. This is in the blood just before they did the PET scanning. And they could find proteins that differ from person to person, but they said none of this was significant.
And other studies have looked at these various inflammation markers and such in blood on a larger scale, and there are some apparent or possible differences between long COVID and people who didn't have long COVID. So that's not surprising, but of course they didn't reach significance here because they only have 24 people.
Yeah, they actually end up saying we need further study
Yeah,
because we can't really rule anything in or out here. We need
yeah.
to look at it some more. They also looked at blood and gut-derived mononuclear cells by flow cytometry to see if the markers on these cells change and do they relate to dye uptake, and the answer is no. There's no relationship. Now, the next thing they do is they say, okay, there seems to be a lot of T cell activity, dye uptake in the gut. So maybe there's something going on there. Other studies have suggested there might be some viral components in the gut, right? So they collect some tissue by sigmoidoscopy in 5 people who had undergone this PET imaging, and they do in situ hybridization where they make sections of the tissue, they put it on a slide, and they hybridize it with a probe to detect viral RNA, and they can find SARS-CoV-2 RNA in several cells in these tissues. They show pictures of it. You can see some cells are positive here. And most of these cells are in the lamina propria. They're not in the epithelium, right? Um,
And they find single and double-stranded RNA,
they do.
right? So that suggests, well, it may suggest that there's replication of this RNA going on.
Yeah. Which, of course,
There are other ways you could get that, of course, but
now the thing is, they do also take the tissue and they do extract RNA and do RT-PCR, and they get zero signal, which tells you the amount of RNA is vanishingly
it's
small,
extremely small.
right? You can see it on an in situ, couple of cells here and there. I don't know what that means, right? And again, I don't see a difference between the recovered and the non-recovered people. I think these are all people who have not recovered from long COVID. Yes, these are individuals with long COVID. What about the others? If you've recovered, do you still have RNA? It's an
And
important.
if you've recovered, how likely are you to consent to a biopsy of your intestine?
Exactly. That's probably it. I feel
It's a,
fine. I don't need a
yeah,
biopsy,
I
right?
mean that's a huge barrier to doing these studies.
Sure.
Is
Of course.
the people who are going to agree to that are people who are out of medical options and feeling crummy, and they're like, okay, yeah, if you think you might find something, but if you feel fine, no, thank you. The PET scan was enough.
And look what they write here. This is very interesting. So the dye uptake in the PET scan in the proximal colon and rectal tissue, which is where they sampled, in the participants who underwent biopsy were at least 3 standard deviations above the mean of pre-pandemic controls. I don't want to know that. I want to know the non-recovered people. So that's the finding, right?
Yeah.
There's some activated T cells throughout the bodies of people with long COVID. Maybe not much different from recovered people who have recovered from long COVID. They think there might be some RNA in the gut, but whether that represents viral replication or not, we just don't know. But they say this is evidence of persistent T cell activation in a variety of tissues. Okay,
Okay.
that's fine. But then they say we found evidence of SARS-CoV-2 persistence in gut tissue, which could be replication, although we can't prove it here, right? But
And
I
they did
think
find evidence of it.
they found RNA, but
They
who
didn't find
knows?
that it was happening. They found evidence of
Yeah.
it.
What if it's just sitting there and it was never cleared, right?
Yeah.
So Is that a problem, or does that happen in a lot of people?
Or, since we haven't had a lot of these tools for previous infections and this level of analysis, what if sometimes when you get a cell infected with an RNA virus, you get some kind of integration event going on or some kind of persistence event going on in a few cells, and those cells are now producing a little bit of viral RNA
Yeah,
along with
yeah.
that's entirely theoretical, but that's where we are at this point.
So they conclude our data are consistent with a model in which persistence of SARS-CoV-2 results in chronic tissue-based inflammation, T cell activation, and perhaps long COVID. However, no causal relationships have, have been verified. And they say,
They are consistent with that model. They are consistent with other models as well.
I think they agree that there are not enough people. We need
Yeah.
larger studies.
What you need is a couple thousand people with and equal numbers with and without long COVID who will all consent to this full panel of highly invasive tests.
Yeah, that's what it's
I
going to
mean,
take, unfortunately.
yeah,
But you need to have recovered people too, not just
that's
people
what I
with
mean.
long
You
COVID. Yeah.
with and without, yeah. So you need a sizable population of people who recovered, have no remaining symptoms, and see what's going on in them.
Because I
And
think,
no, I am not consenting to have a gut biopsy. Thank you very much.
well, a lot of people get colonoscopies, right?
Yes.
You could say, while we're in there, do you mind if we take a
Do you
snip
mind if
of?
we take a yeah,
I
okay.
mean, I would be okay with that because I understand, the value, but I'm not sure everyone would be. And if a lot of people have polyps that are taken out, but I don't
Yeah.
want to just focus on polyps. That could be aberrant, right?
Yes.
So it's a tough question. But in my view, look, if you think it's virus replication, and somehow you got to find infectious virus there, because a lot of people have said, oh, it's really hard to find infectious SARS-CoV-2 in the gut. Well, maybe there isn't very much, and maybe it doesn't mean anything, right? So that's the key. Or to develop an animal model where the virus reproduces in the gut and they have, although, long COVID is a reported thing, right? So it's hard to have an animal do
Yeah,
that.
a lot of it is there might be some assays you could do for testing an animal's sense of smell or uh, you know, mental performance on tasks of some kind.
Yep.
Can they get out of a maze or whatever? So there are ways to get at that indirectly that might be informative. And I would say, even if you can't directly measure whether the mouse is having exactly long COVID symptoms, if you could demonstrate that the virus actually persists for weeks or months in some compartment in the mouse, I think that would be very interesting to know and very interesting to study.
Well, many years ago, Diane Griffin showed that Synbis virus persists for many, many months after infection, which was very much surprising, right?
Yeah.
And it wasn't even infectious virus; it was just viral RNA
Hmm.
sitting around in various cells. And we always thought, an acute infection, it's over and the RNA's gone, but apparently it's not. And that's never been really extensively validated in people
Right.
for reasons that we've talked about. Healthy people don't want to have invasive things done to them. So it is a question needing answering, especially in light of a post-acute disease like long COVID. If you think, viral RNA sticking around is part of the problem, you really need to look at that.
If you could do a really big study looking at samples from autopsies,
Hmm.
you'd have to go globally or at least nationwide across a large nation, but to find enough folks where the next of kin would consent to this. But and you'd have to get them early enough after death that stuff hadn't degraded. But that might be another route to get at this. I don't
Hmm.
know.
As long as you can have some recovered controls, right?
Yeah. You could also look at the many, many wild animal species that are known to be carrying SARS-CoV-2
Mm.
on a regular basis. There is no shortage of deer carcasses every fall, everywhere across the U.S. Maybe have some program with hunters, turn turn in a piece of gut while you're turning
Yeah,
while you're getting your kill checked. Um,
yeah,
and
to see
just a
where.
thought. See if you can find
Yeah,
persistent
yeah.
virus. And I don't know how you'd distinguish that from ongoing infections in the deer population, but there might be some way to get at
Well,
that.
you could have, say, you get a respiratory tract sample,
Yeah,
and you say, "Oh, there's no virus there anymore,"
but here it
um,
is in the
but
gut,
here it is in the gut. Yeah.
right, in very small quantities. That might work.
Mm.
I don't
In
know.
other animals too.
Yeah, just throwing out ideas. But yeah,
So,
this,
you know, I think this is a very valiant attempt,
yes.
but it's not there yet.
Yeah, I don't want to detract from the amount of work and the effort that these folks have gone to. It is
Yeah.
important, and it is a tremendous amount of work, and kudos to them on a difficult paper that is mostly negative results, and kudos to science for, science translational medicine for publishing a paper that's largely negative results. But this is the kind of thing we need.
Of course, what they say here is that we identified SARS-CoV-2 RNA in participant 3 people up to 676 days after their initial infection, which sounds, oh my gosh, but it's 3 people out of 24 and pieces of RNA. We don't know anything more than that. So I don't know
Yeah,
what it means, and it could be in everybody, right? So, well, it's not in everybody. It was only in 3, right? So
right.
I don't know what that means, but that's how science works.
Yep.
You don't always get the answer right away. Got to keep trying. Okay. Our other paper is about influenza virus. It's Nature Communications. A H2N2 and A H3N2 influenza pandemics elicited durable cross-reactive and protective antibodies against avian N2 neuraminidase.
And the authors, single first author, Xiaolan Liang, and two co senior authors, Mark Zenin and Suksen Wang. And this team is from everywhere. I highlighted, they're on multiple continents. Nature does this annoying thing. All the affiliations are at the very, very end.
Yes,
So they're
very
University of
annoying.
Hong Kong, Guangzhou Medical Center, Guangzhou National Laboratory, South China Agricultural University, Shantou University, Indian Institute of Science in Bangalore, the US CDC, Center for Immunology and Infection at the Hong Kong Science and Technology Park, St. Jude Children's Research Hospital, the Laboratory of Data Discovery for Health at Hong Kong Science and Technology Park, and the National Veterinary School of Toulouse in Toulouse, France. So this is, really, really a worldwide team.
And one of the authors is Richard Webby,
Yes.
who was on TWiV not too long ago talking about H5N1 in cows.
Yep.
And so avian influenza virus, this is H5N1 is an avian influenza virus, and that's in the news, but there are others. Um, there are 13 different avian influenza virus subtypes, and apparently, since these have been tracked, 1996 in humans, there have been 2,739 reported human cases of infection with 13 different avian influenza virus subtypes, including H5N1. There are also H7N9, H9N2. Those are responsible for the majority of infections. And one of the things they're interested in this paper, well, first of all, the neuraminidase, which doesn't get a lot of
Yeah.
attention, right? The two spike proteins on the virus particle, hemagglutinin and neuraminidase. Hemagglutinin gets most of the attention, right? Because
It's easier to
antibodies,
assay, right?
easy to assay, antibodies to the hemagglutinin, it can be neutralizing, but also, as you'll see here, anti-neuraminidase antibodies can be neutralizing also, and they try and give us some information about those. Now, one of the things they're interested in is there's kind of an age dependence of these avian influenza virus infections of humans. So most of the H5N1 cases are in people less than 15 years old, while the H7N9 are mostly in people older than 60. And so they want to understand what's the basis for that.
Yeah.
speaking of HA and NA, by the way, I think it was maybe last week or 2 weeks ago, we talked about a framework for pandemic threat assessment of influenza viruses, and that's developed by WHO. We did a paper where they used that to look at some, I think it was some bat influenza viruses,
Right.
but mostly they focus on antibodies against the hemagglutinin. But they say, maybe we should expand it, and this paper gives some evidence to help expand that as well.
And this paper, by the way, excuse me, is open access, Nature Communications.
So the most prevalent subtype in poultry is AH9N2, avian influenza virus. These are the predominant circulating strain in poultry in China. There have been increases in human infections, specifically in young children. And there's also, they've done serological studies in China uh, looking for antibodies against this virus. And between 1 and 11% of people have have been occupationally exposed to this virus. So people who work with chickens, for example. All right, so H9N2. So it's a H9 hemagglutinin and N2 neuraminidase. And that N2 is the same as H3N2 human viruses, right? The seasonal H3N2. That's very similar to the N2 of these avian influenza viruses. The N2 of H3N2 was introduced into humans in 1957. So from 1918 to 1957, an H1N1 virus circulated. In 1957, that was replaced by an H2N2. So now we
Right.
have the N2 neuraminidase, which still is around today in the H3N2 viruses and also in those H9N2 avian viruses. They're not exactly the same, as you will see, but they're related.
So this is one of those antigenic shifts that happens in flu periodically. And 1957, that was a flu pandemic with this H2N2 strain that I gather was pretty serious, right?
Yes. Yes. Okay, so what do we do here? First, they look at sequences of avian and human N2 genes, 103 different sequences that we've got since 1957. And there are two branches. The human and the avian sequences are in two branches, which means they've evolved independently since their introduction in 1957. And they say the human N2s are like a ladder, which is an immune response driven evolution, whereas the avian N2s are more balanced, showing there hasn't been a lot of selection pressure on the N2 in birds. The N2s from the 1957, the human N2 from 1957 to the early 70s was really similar to the avian N2, about 90% amino acid identity. And then after 1970, they diverged. In the last 20 years, only between 75 to 80% similarity with the ancestral avian N2. So they've been probably by immune pressure, they've been diverging in humans and become different. But the question now is, how much cross-reactivity are there among all these different human N2s from 57 to the present and the avian N2? So they do a series of experiments to look at that question. And the first one is, can we find cross-reactive avian N2 antibodies in people?
Right.
Right. So in other words, we can bleed people and make serum from them and ask, do they have antibodies that will react with an avian N2 neuraminidase? So they have a panel of people from Guangzhou Medical University, and they have serum samples from them. And they're going to use them against a panel of H9, avian H9N2 viruses, as well as human H3N2 viruses, right?
Right.
And so first, they look at hemagglutinin antibodies. There's an assay called hemagglutination inhibition. So hemagglutination is an assay where you mix influenza virus with red blood cells and they stick and they form a little web in a tissue culture well.
Which is why hemagglutinin is called hemagglutinin.
Yes. And if you inhibit it with an antibody against the hemagglutinin, you don't get that little web. You just get red blood cells tumbling to the bottom. So these people had HI titers. In other words, they have antibodies against HA, against the more recent H3N2 viruses, but not against avian H9N2, because H3N2, human H3N2s has been circulating since 1968. So that's not surprising.
Right.
The peak titers are correlated with the virus that circulated within the first decade of the birth of these people. So they know how old each of them are. And they can say, so you have the highest titer against this virus that happened in your first 10 years of life or was circulating. And that makes sense because, we have this idea for influenza virus that the first exposure you ever get to influenza gives you immunological memory that then is boosted later on by a cross-reactive virus.
Your
Right.
first
So
flu gives you, primes you and biases you for everything that comes after.
exactly right. But then they look at the neuraminidase inhibition titer. So you can do a similar assay with neuraminidase inhibition. Those are consistent in an age-dependent manner. So the older group, 65 years and older, had the highest titers to all 8 of these strains, while the youngest group had very low neuraminidase titers. So again, the neuraminidase antibodies are behaving in an age-dependent manner. Now, this neuraminidase inhibition assays don't look at infectivity, so they wanted to do that. Do these antibodies protect against infection? So they passively transfer the human sera into mice, and then they challenge them, and they basically find that again the sera from people 65 and older have cross-reactive antibodies that protect against H9N2,
Right.
the avian virus. Right, so these people were 65 and older, which means they were around in the 50s.
In the 1957 pandemic, yep.
And so they have antibodies that cross-react with the avian N2. And remember, in this 50s and 60s, the avian and the human N2s were much closer than they are today in terms of
Right.
amino acid sequence. That was the first result that they found here.
Right. So we know these older people haven't been exposed to H9N2 recently, but they've got these cross-reactive antibodies, which
Right.
must have come or most likely came from their exposure to H2N2 when it spilled over into humans in 1957.
Now, in these experiments, they're using viruses. So they say, well, maybe there's some hemagglutinin antibodies that are confusing us. So they make pure protein, and they make the hemagglutinin, and they ask, are there any hemagglutinin binding antibodies in these sera? And basically they say, we don't think that's part of the issue here. All these effects that we're seeing is neuraminidase
Right.
antibody based. Okay, next, so there's cross-reactivity. Is it the case that exposure to these older human N2s, 57-ish, right, is a determinant of cross-reactivity? So they do a prime and challenge experiment in mice. So they're going to immunize mice, and they're going to challenge them and see if they get infected. And they prime them with a 68 human N2, H3N2, and then they make viruses. This is the beauty of being able to make viruses at will. They can put any HA and NA that they want. And so they can keep HA constant and NA or different. You can vary anything you want. So
Right.
basically, they're going to challenge them. They're going to prime them with H3N2 or a H3N2 from 2016 or a H1N1 from 2015. So the 68 is the early H3N2 virus. And then the 2016 is the contemporary H3N2, and then H1N1 is different, completely different virus. Basically, they show that the AI, this 1968 virus, and the virus, I got my letters confused. The where's ZJ, ZJ19 control virus, H1N1,
Right.
They have cross-reactive epitopes that are closer compared to the 2016 virus. Okay,
Right. And they used so in this experiment, they used the 1968 H3N2
that's right.
virus, not the 1957
That's right.
H2N2. And why was that?
So they used the 1968 um, and the 2016, so an older one and a
Right.
contemporary one. Why didn't they use the 57? They're going to do that subsequently.
Right. Right. Oh, yeah. Okay.
I don't know why they didn't do it initially here. This is a good question. But they're just asking whether the 68, being infected with the 68 virus is enough to induce protection against the
Right.
avian N2 virus. And the answer is yes, it
Yes.
is. After ZJ19. What is ZJ19? I've got to go back and check because we're going to
Yeah.
use that. Okay. ZJ19 is
It's a 2019. It's an
C. Here we go. So it is
H9.
a H9N2. It's an avian virus from 2019.
Yes.
Okay. ZJ19 is an avian N2 from
Yes.
2019. And the
A
result,
chicken Zhejiang. Got it.
so both the 1968 H3N2 and the 2019
2019.
H9N2 are closer compared to the 2016 H3N2. Okay. That's the finding, even though the ZJ is from 2019. This 2016 and the 1968 are closer. Okay, so then they say, let's demonstrate the role of the neuraminidase to protect against infection. So they do another prime challenge experiment where they make viruses with the neuraminidase from the 1968, the 2016, or MI115, which is that's the Michigan 2015. These are human viruses.
Right.
And then they challenge with viruses. And when they've primed with these three viruses, all the animals survive the challenge. So they're all cross protective, although they boost antibodies to different extents. And then, so they've done this prime boost, this prime challenge. They want to know now, are the antibodies against N2 what's protecting these animals? So they immunize another set of mice, and then they take sera from those mice and transfer them into naive mice before challenge. And in fact, they show that N2 antibodies made by priming with the 1968 N2 are protective against lethal infection with avian H9N2. Okay, so remember, H3N2 from 1968, if you prime with that virus, it will protect you against lethal infection with H9N2.
Right.
Then they also look for cross-reactivity to other neuraminidase subtypes. So they have a subset of human serum samples from people who have no history of influenza vaccination. They haven't been to a poultry market. They look at antibodies in them to various influenza viruses. 20% of them have H9 antibodies, right? H9N and 2 avian influenza that we're talking about. They have antibodies to H9, but they haven't been to a poultry market. So there's obviously some cross reactivity going on there, and they want to know where this is coming from. So they make recombinant viruses with an H6 hemagglutinin, all with H6 and different neuraminases, just to keep the H the same and to be an irrelevant one that these people don't have antibodies to. And they make viruses with N5, N3, N7, N9, and basically they show that um, you can get cross reactivity against all these other neuraminases in the older people,
Right.
60 to 69-year-old people have antibodies against a lot of neuraminidase subtypes.
I was interested to see. So they have this sizable group, 1,500 or so older adults. Then the cohort is 60 to 88 years old, with no history of influenza vaccination.
Correct. So it's interesting,
Eh,
right?
yeah, I is that. Did you have to look hard to find older people who hadn't ever gotten a flu shot, or is it not typical in China to get a flu shot when you're
I guess you can find people who have not been vaccinated.
I mean, I'm sure you could if you looked in the United States, I'm sure you could find a population this large of older people who have not been vaccinated for whatever reason.
Yeah.
But it just stuck out at me like, wow, that's a lot of people who should have flu shots who didn't.
So I'm glad you bring that up because I made a mistake when I was describing that cohort.
Yeah,
So this is 1,532 older adults. They're collected between 2015 and 2017. They have been infected with H3N2 viruses.
right.
They have no history of flu vaccination, as you say. 37% of them have reported visits to live
The
poultry
live poultry
markets in the
markets.
last 12 months. I said they
Yes,
didn't, but
they
they
didn't.
did.
Yeah,
And that's why 20% of them have antibodies against the H9 of the
yeah,
H9N2 virus, right? Because they've been to poultry markets. Because there's no H9 human hemagglutinin, but they've obviously been infected with some H9N something avian influenza virus by visiting the poultry markets. So that's spillover, right?
right.
I mean, it's not a pandemic. It just shows you the frequency
Wait,
of
so that
spillover.
oh wait. I just reread this paragraph. That's not the 1,532. Um, okay. So they took a cohort of 1,532 older adults. Okay.
Yes, they found that
Then
they have antibodies
they
against
they look
avian
at
hemagglutinins.
PCR confirmed cases in adults 60 to 88
Hmm.
who had no history of flu vaccination, and 37% of those 43 cases had visited live poultry markets.
That's
So
right.
it's not 1,500 people with no 1,500 older people with no flu vaccination. It's 43 who had confirmed cases, right? Who had also not been vaccinated. It's a little confusing the way this paragraph is
Yeah, you're
structured.
right. The people who got H3N2, 37% of them were not vaccinated. Yeah.
Right, and that's the 43 PCR confirmed cases. So
Yeah.
it's the subset of people who got the virus. 37.2% of them had visited live poultry markets, and these were people who had not had flu vaccination. Um, and now it makes a little bit more sense.
And this cohort, among them, the 60 to 69-year-olds have antibodies to different neuraminidases,
Right.
not just N2, but N3 and N9. So, they say they could be exposed to H3N2, human H3N2, and that would boost the avian N2 antibodies. But maybe that can also boost neuraminidase titers in people who are infected with other neuraminidase subtypes. So anyway, if you're visiting poultry markets, you obviously can get infected with avian influenza viruses and you don't even know it because you didn't get
Yeah.
sick.
You should still get your flu shot.
You should get your flu shot, although it's not going to help if you go to a poultry market, right?
Well, I don't know. It might. It depends.
Well, yeah, if it's an H3N2 vaccine,
Yeah,
it could help you against H9N2, right?
sure.
So then they stratified avian neuraminidase cross-reactivity by year of birth, right? So they looked at the data and they found distinct reactivity profiles with respect to the 1968 N2 titers. People born between 57 to 68, that would be 52 to 63, had high N2 titers, human N2 titers, but modest reactivity to avian N2 strains. So they're born between 57 to 68. In contrast, people born prior to 1957 had high N2 both against human and avian N2. Isn't that interesting? So,
It is, and it speaks to the, your first flu is influential, right?
mhm,
Because the people born in 1957 to 68, probably their first flu was the 1957 pandemic
mhm,
flu or
yeah.
its descendants, whereas people born before 1957 um, may have had flu before that, and then the 57 pandemic was a subsequent infection.
Hey, I'm surprised that having that H2N2 didn't give them titers to avian N2.
Yeah.
I would think it would.
Or maybe there's some odd thing going on with the immune system where they built a less robust response when they were first exposed. I don't know.
Anyway, there was this virus ZJ19, which was a 2019 H9N2 virus, right?
I think
Let
that's
me
right.
let me just check that. I should have made a table here.
I
Yes,
should.
it's a
Yeah.
2019 H9N2. So some human sera neutralized or protected mice from infection with that virus. And they say, well, it must be that these people from 40 to 65 years of age have antibodies, cross reactive antibodies against that virus. So 40 to 64 years old are people with high antibodies to both human H3N2 1968 and avian N2. All right. So then they ask, is having been exposed to the 57 pandemic, does that give you avian N2 cross reactivity? So they have, again, serum samples from, this is from a different community study in Hong Kong. They have 105 samples. They test for antibodies against N2 from 1957, 1968, and two avian N2s. N2 titers to 1957 were the highest in those born before 57 and gradually declined thereafter. And N2 titers to H3N2 68 were not different between those born before 57 and those born between 57 and 68. So they say it's likely that exposure to the 68 N2 elicited antibodies that can cross react with avian N2 in the naive population while boosting pre existing N2 antibodies, resuling in higher avian N2 titers in the pre 57 cohort. So it's actually the 1968 exposure that boosts your antibodies
Right.
pre 1957.
It's like the second shot of vaccine,
Yes.
except this was the real virus.
All right. So let's summarize. This is a little confusing. First, older adults have high titers of cross-reactive neuraminidase antibodies against various avian N2 viruses, probably conferred by exposure to both 57 and 68 pandemic viruses. And in their mouse studies, these antibodies are protective. And even today, if you get infected with H3N2, you can recall some of those N2 antibodies from the original 57 or 68. That you have to be old enough, of course, right? All right. So there's a nice figure here that shows a neuraminidase cross reactivity profile, and they say there are three um, patterns. First, high antibody reactivity to the N2 from 57, 68 and avian N2 in people born before 57. So if you're born before 57, you have antibodies against 57, 68 and avian N2 neuraminases. Second, high N2 1968, but moderate N2 57 and moderate avian N2 reactivity in people born between 57 and 68. And then three, declining N2 1968 and low N2 57 and avian N2 reactivity in people born after 1968. So those people never saw the 57 pandemic, which would
Right.
have been their first exposure and primed them to that N2 neuraminidase. So basically, they think that people born prior to 57 probably were exposed to a avian origin N2. circulating. We don't know. It must have been circulating before because it gave rise to the 57 virus. Well,
Right. And
those
remember,
born.
the study is happening in China where the 57 virus probably first spilled over.
That's right. That's right. And then people born within a decade before 68 would be exposed to the 68 N2 that drifted from the 57 N2 as it adapted in humans. So it was slightly different. And then, so you get a different cross protection with both 57 and the avian N2. And then the people born after 68, further human adapted N2. So you get more human like N2 reactivity and less avian and less 57. So that is the impact of neuraminidase antibodies, and your history plays a good part
Yeah.
in how you're reacting today.
And they make the important point that we probably ought to look at neuraminidase immunity in assessing pandemic risk of various
Yes,
flu strains in animals, which the WHO currently looks at HA. What's the population immunity to this particular HA? But maybe it's well, I would say based on these data, definitely it's worth
yes,
also considering
for sure.
NA immunity in the population, and if that's low, then that's a higher risk, and if it's high, then that's a lower risk for the pandemic.
So cross-reactive and protective avian N2 antibodies are present in humans in an age-dependent manner, depending on whether you got infected in 57 with H2N2 and subsequently in 68 with H3N2, which was closer to the avian N2 back then in 68. Today, it's a bit.
Today it's
If you get
diverged.
your first infection today with H3N2, you're going to have very little cross protection against avian N2.
Right.
So yes, and as Alan said, we should put neuraminidase into our pandemic risk assessments for sure. Yeah. So neuraminidase, pay attention to neuraminidase,
Pay
and
attention to
when
neuraminidase.
these different pandemics of influenza are very interesting in terms of people who get infected first with those pandemic strains. It determines your cross reactivity.
Yeah.
So I was born in 1953. I assume I was exposed to something before 57. So maybe I have good cross
You
reactive
probably
avian
have some
N2.
cross-reactive immunity against avian flu. Yeah.
Yep. Okie dokie. So let's do some email.
Sure.
Can
You
you
want me to
take?
take the first one?
Yes, please.
Tom writes, a suggested place to look for a host for science in an age of politics. I think you would find these two sympathetic. And he links to an article, Two Leftist Bros Dive into Conservatism to Know Your Enemy in the New York Times. Despite being described in the linked article as leftist, I don't think they are. They are indeed extremely critical of the right, but not in a knee jerk or partisan way, and they are literate and thoughtful in a way which I think you would very much like. Their area of expertise is definitely politics rather than science. I don't know if anyone is both, but if there is such a person, I think it likely they would be able to point you to them.
Hmm.
And then Tom concludes, very often when your listeners respond, they very warmly express appreciation. This is for very good reason. Your erudition, seriousness of purpose, and lightheartedness give me hope for humanity. TWiV is one of the treasures of our civilization. Thank you, thank you.
Oh,
Well,
that's
thank
very
you, Tom.
nice.
It's very kind.
So I found this New York Times article about the two leftist bros.
Mm-hmm.
It's these two guys recorded in New York, and they say they're self-described recovered conservatives. They're must listen for the sort of person who is as interested in the internal politics of national review as in the current jousting on Capitol Hill. The podcast contextualizes today's hot button debates, like the battle over critical race theory in schools, but mostly offers deep dives into conservative intellectual history, going into the weeds of the weeds, armed with reading lists, reams of footnotes, and archival documents. Its audience of roughly 25,000 to 50,000 listeners per episode, which is very similar to TWiV.
That's pretty. We're on a par with that. Yeah.
has emerged as something middle-aged liberals, young democratic socialists, and Gen Z conservatives hunger for deeper perspective on the tumult of the Trump era. I don't know. It sounds interesting. Have you ever listened?
Yeah. I haven't. No.
So last time we asked who would be good to bring on TWiV to talk about the growing politicization of science, and so these are some suggestions. But that one was from Tom. The next one is from Susan. In your last episode, you asked who we would suggest for a guest to discuss the intersection of politics and science. You had Lori Garrett on before discussing aspects of public health. I think she would be an interesting future guest to discuss many of these topics as it pertains to the recent SCOTUS decisions, etc. As always, I love your suite of shows and always learn so much from all of you. Thanks for all you do to keep us sane in a mad, mad world. Yeah, I think Lori Garrett would have a handle
Sure.
on that, right?
Yeah.
That's another good one. And we can have more than one person, of course.
Yes, we could.
All right, you're
And
next.
another one from Molly writes, Hi, TWiV team. When I heard your recent call out for recommendations for experts on the politicization of science, I wanted to write to suggest a colleague, the journalist Naomi Klein. Klein is an investigative journalist whose most recent best-selling book, Doppelganger, covers the topic extensively. The book is excellent, by the way. If you haven't read it, I highly recommend. She is faculty in my department, and I'm happy to help provide contact information if you're interested in trying to book her for the show. Thanks again for all the work you do. Best, Molly. That sounds like another excellent suggestion.
Have you read Doppelganger?
I have not, no.
That sounds like
Not
a
yet, I
must
should
read.
say.
All right.
I have a long list of, on my local library's website, I can log in and list books I'm meaning to get to, and I have a sizable backlog.
Glenn writes, as scientists, I'm surprised that you would accept the Reuters story at face value and without serious questions. I think the last few years have shown us that most media narratives need to be accepted with caution. So this was the Reuters article about the Pentagon's activity against China vaccines, right?
Yep.
When I went back and read the original story you referenced this week, I was struck by an astounding lack of information to support the reporter's thesis of a Pentagon misinformation campaign against the Chinese vaccine. First off, the confirmation source cited was a so called senior defense official without a name. Sounds suspicious, but fine. Sources often don't want to be identified. I'm curious as to why this individual came forward and if they did and why. And how senior? And senior where? Chief of the custodial staff? Such vagaries detract immediately from authenticity and become a serious red flag. We've spent the better part of the last decade being assured the media's sources were impeccable, when in fact they had been bought and paid for, including senior intelligence officials. Then the story reported that multiple tweets were posted ostensibly surreptitiously by the Pentagon without a single example. Granted, they did say that they'd been taken down, but without that evidence, all of this is just unsubstantiated rumor. And so far, you've had to take all the evidence on faith of the reporter's honesty and professionalism and lack of bias. I know for a fact that none of my instructors or mentors would have accepted any thesis or dissertation of mine based on this kind of evidence. I'm sure none of you would either. Finally, I can think of at least one player who could and would have benefited and planted such a story to discredit our government. Personally, I find it difficult to believe that the Pentagon would have done this kind of campaign as policy, yet it's possible and possibly by an unauthorized faction. But as you pointed out, as an attenuated virus, Sinovac was not a great vaccine, so there might be at least two alternative stories here. One, that the Reuters story itself was fabricated and planted to discredit us. We've seen that done a lot lately. Or second, that some entity was cautioning against the use of the Chinese vaccine because of its limited efficacy. Not seeing the tweets, it's not possible to determine what the actual wording was. Scientists, to maintain absolute credibility, need to avoid any possible hint of a lack of objectivity. We are Caesar's wives. As academics, we are so constantly bombarded with viewpoint that it's difficult to remain totally and infallibly objective. However, I so respect all of you for your expertise and knowledge that I hold you to that very high standard. Respectfully, Glenn.
Okay. Couple of
Yes.
clarifications here from a journalist. Believe it or not, there are professional ethical standards in the field of journalism. Now, if you watch a lot of Fox News, you would not believe that, but it is true. And Violating those ethical principles can get a reporter into a tremendous amount of trouble, particularly if they work for an outlet with the profile of Reuters. Um, I can't cite a source for this, but I can virtually guarantee that this story was vetted by multiple levels of editors at Reuters whose jobs are on the line if they screw this up. When something is anonymously sourced, that is done with consideration. And so you want more information about who the confirmation source is, like what department are they, how senior. The problem is that if you start printing where they are, how senior they are, it rapidly becomes very easy for wherever they work to figure out who they are and to fire them. So when you cite an anonymous source, you have to be very careful about protecting their identity. And there's also legal precedent on this. Reporters have, served time in jail to protect the anonymity of their sources. Um, and this is standard practice to give a rather generic description that is provably accurate, would be provably accurate if somebody had access to the full information. And again, that's where the editors come in. They would look at this. They would say, okay, who was the source? How do we describe them? Um, and that would be vetted. I mean, yes, in a sense, we are taking the word of Reuters as an organization on this. And it is possible that they screwed up, that this is somebody pulling their leg or somebody planting a story. However, they did post at least one example of a tweet, which I think was in Tagalog, and they had a translation of it. It was a
Yeah.
tweet that posted. It was targeted at a Philippine audience. Um, so that is some evidence that this occurred. And yeah, you say none of your instructors would have accepted a thesis on this. Well, standards for a thesis are different than standards for an anonymously sourced article. If you were doing your thesis in a graduate program in journalism and you managed to get a scoop that was anonymously sourced, you would go through this same type of process. As far as finding it difficult to believe the Pentagon would do this type of campaign, I suspect you haven't read much about the history of U.S. Defense policy over the years, through the Cold War, through the Vietnam War, up into, just the stuff we know about that was done in the 80s under Reagan with the Iran-Contra affair, the planting anti-ship mines in Nicaraguan harbors, and more recently, the CIA, which is not the Pentagon, but is closely aligned in tactics and interests, conducted a fake vaccination campaign in Pakistan to locate bin Laden. That's documented. This is the kind of thing that these folks get up to because it is their job to do this sort of thing, but there need to be balances on that, and one of those balances is this type of investigative journalism. So yes, we gave credibility to the source. It was typical of these types of articles, and I do believe it was vetted. I do take your point that we can't be certain that this is true.
So I just Googled, and basically Reuters was the initial reveal, and then every news agency after that is repeating it,
Yeah,
right?
yeah. Reuters is a wire service. That's kind of their job, is to um, run stories that everybody picks up.
So we have the Al Jazeera, Washington Post,
Yeah,
Scientific American, Forbes, South China Morning Post, Xinhua, YouTube,
sure.
Democracy Now, New York Times. They're all
Yeah,
repeating.
yeah. They're citing, and that would happen too if the Washington Post or the New York Times or some other outlet broke the story.
Yeah.
And then Reuters would be citing it, and all these other sources would be saying, according to a story in the Washington Post, yada, yada, yada.
And so I presume there'll be follow-up investigations, maybe?
If they can get more information, sure. I mean, investigative journalism um, is the hardest reporting in journalism.
Mhm,
Science journalism is the hardest writing.
mhm,
My reporting job is trivial. I call up a researcher and I ask them what they're doing, and they love to talk to me
mm.
once they return their phone calls. But But investigative journalism is the opposite problem. So for me, explaining the science to a broader audience is the trick. For an investigative journalist, explaining the story is trivial once you can actually get it. And the getting it is this process of finding ways and relationships
Mm.
to obtain information from organizations that don't want to give it to you. So there's a reporter who knows somebody at the Pentagon who is willing to talk to them on the basis of anonymity, and who is apparently credible. And depending on the amount of information they can get from that and other sources, we may find out more.
So if
Or if this triggers an investigation.
so, South China Morning Post said they asked the Pentagon and they declined to respond. Does that
We have
mean
no comment on
anything?
that matter. We can neither confirm nor deny the existence of
I mean,
any
if
military.
they didn't do it, would they say no, we didn't do it?
No,
They wouldn't even bother.
they wouldn't.
Yeah.
Their policy is that they don't like to talk. It is possible that there will be some kind of congressional or executive investigation of this,
Mhm.
or somebody higher up in the Pentagon. Some general will say, "Did this really happen? Did I authorize this?"
Yeah.
Somebody with the authority could come down on it, and that's the benefit of investigative journalism
Right.
to society.
Well, the way I look at it, I think people sent us someone sent us this article and we just say, "Here's what someone sent us." I
Hmm.
probably said it was a horrible thing to do,
Yeah,
but I understand I should be more critical, but I have no basis for doing that with an article like this.
I am critical of it, but I tend, if the source seems credible and if the facts hold together and fit with known observations, I'll entertain it, and that's what we did on the episode, was present it and say, if true, this is pretty appalling.
Okay. All right, Alan, take the next one, please.
Sure. Walt writes, regarding John's letter in episode 1127, John wrote, quote, "I seem to remember that it was our politicians creating the poor decisions which didn't help our investigating team. This doesn't excuse a horrible action." End quote. He and perhaps others might like to consider: 1. Geopolitics has always been a game, like pro basketball, played with sharp elbows. There is no first foul. 2. We won't understand the Trump administration antagonism of China without understanding its roots. In 2018, Bolton came into the White House and on his first day eliminated the NSC Office of Biodefense, squeezing out its leader. The rationale was that the only biological threats needing White House level coordination were state actor, i.e., bio-war ones. This wasn't new to the paleoconservative Bolton. It goes back at least to Reagan's Cold War rhetoric. But early in 2020, it provided freshly plowed ground for alt-right claims of COVID being a biowar effort, claims that our national security types picked up that same year, claims that morphed into a lab leak origin and obviously continue to this day with suspicion of intent still attached, unspoken. You may recall that early in 2020, Trump praised Xi for his very competent handling of COVID. It was only later, when Trump saw the disease as a greater threat to his reputation, that the scapegoating of the CCP's virus and scientists who'd work with WIV began. Okay.
Right.
But it was not much later. It was still in 2020 that the scapegoating was going on, and the this was also not the first not the first shot fired from the Trump administration toward China. Didn't he say, "I like trade wars," and impose a bunch of tariffs? So
Mm.
this was running antagonism. But I take your point about there's no first foul. Geopolitics, yeah, this is the way this goes.
All right. Flint writes, "I just discovered your podcast. Thanks for sharing information in that format. My comment is about the answer to Alina's question during the Q&A June 28th podcast. She references an article in Biomedicines on spikeopathy. This was during clinical update, right?
Hmm.
Someone wrote in to Daniel about this review article, it's kind of a meta-analysis claiming that spike protein, whether delivered by infection or vaccination, is toxic. It invades every organ, et cetera, et cetera, et cetera. And Daniel said, no, it's,
No.
there's no evidence. This is all wrong science. And that's what Flint is writing about. The respondent relied on authority, that was Daniel, to negate the claims made in the study and did not, as Alina requested, consider the article specifically. I studied it briefly, and I think to reference a source about misinformation in science should have at least been included in the answer to allow Alina to see why that article should not have been published. Or else, in 2 sentences, explain how the problems in that psychiatrist's review of the literature should not have made publication. I think you've answered your question. Psychiatrist's review of the literature?
Oh, the virology literature? Okay, yeah.
I know many of the patients who come to primary care medicine for their 20-minute office visits have spent at least that much time on misinformation to inform their decision to forego our advice. They need tools to sort valid information from misinformation. So I understand. The thing is that what Daniel said is that the claims are not supported by any data. Without going through them one by one, which he doesn't have time for on that 40-minute program anyway. And he said there's no evidence that spike is a problem in any format. So all of these claims are incorrect. Now, so where would you do that? I don't want to do it here on TWiV. I don't want to talk about a meta-analysis of faulty data.
And also by restating the analysis point by point. I mean, we did this with the New York Times
Right.
editorial because it was a particularly egregious example, and we know our audience, and we can do that. But there is a very real risk, and I talked about this in my talk at the ASV meeting, that when you do these kinds of myth-busting things, you may reinforce the misinformation simply by repeating it. So yeah, you don't want to give oxygen to this kind of thing. Um, at the same time, I understand Flint's point that it's important to provide a context. And it sounds like I have not listened to that episode, but it does sound like Daniel did that. Maybe to Flint, it seemed a little too brief. And Flint, by the way, is an internal medicine physician in primary care, is the signature in the email. So, as someone, obviously somebody who's living this, as patients come in and present misinformation and demand stuff. But yeah, I mean the upshot of there's no evidence to support the claims. That's a pretty straightforward analysis, I think.
So here on TWiV, we talk about data. We talk about good science, right? We don't debunk things in general,
In general.
right? There are other podcasts that do that, and it's something we never have chosen to do. So if there's a poor article, we're simply not going to cover it and say this is a poor article. It wastes your time and ours, right? I'd rather highlight the good stuff. Okay, let's do one more, I guess. Here, well,
Okay.
we
Is it
have.
my turn?
Is it?
Well, only two of us. We ought to be able to keep track of whose turn it is. Yeah, I think it's
It's your
mine.
turn, yeah.
Ken writes, Honored professors, I don't expect this message to be read on the show. Oh, too bad. But I want to provide some feedback that might boost the impact of your vital mission of science communication. After 4+ years of enthusiastic listening, I know that each of you is not only expert in your fields, but passionate about sharing your love of science. That is why I was disappointed on TWiV 1127 when Dr. Racaniello didn't acknowledge that the participation of citizens and politicians is absolutely necessary to letting the public understand the contributions of science. In her letter, Mifi articulated well about the perception of lay listeners when you dismiss the role of active oversight. Dr. Dove acknowledged the relevance and value of Mifi's feedback, but Dr. Racaniello instead doubled down on his prior concern about the intrusion of politics into science. I firmly agree that expertise must be paramount, but you must realize that statements denying the importance of it in a democratic society of regulatory controls, you are just reinforcing the talking points that elitist ivory tower dwellers have too much sway. Definitely raise the concern of partisan dicta, but please take every opportunity to talk about how scientists are part of society, not separate. Your mission of sharing the value of the scientific approach as well as its applications is incredibly laudable. Please maximize the impact of every piece of content you share. Thank you for all you do, Ken.
Well, I didn't double down on his concern. Well, yeah, I did double down. I didn't say that citizens and lawmakers shouldn't have a role. I said they can have a role. They just need to know what they're talking about. Okay? That's all I said. What's wrong with expertise? They can get people to consult with them. If you have a House committee that wants to look into something, get some experts who know what they're talking about, not Robert Redfield, who thinks that the virus came from a lab. That's absurd. Okay. That's what I'm railing against here. And the recent attempts to regulate science just appear to me to be coming from an area of ignorance. That's why I'm a little pissed off. I'm not an ivory tower dweller by no means. I left the ivory tower to delve into podcasting, for God's sake. I'm not an ivory tower person, but I do appreciate expertise. Okay. I don't know what you do, Ken, but we had an ID doc, an internal medicine doc. They have expertise. I appreciate that. Journalists have an expertise, et cetera. And if you're going to try and regulate science, and I agree, government needs to regulate science, people need to participate. Come on, just know what you're talking about. Don't make a blanket statement of we're going to ban gain of function. Okay? It's ridiculous to do that. It makes you lose credibility. That's all I'm saying. And as you said, definitely raise the concern of partisan dicta. That's what I was doing. But take every opportunity to talk about how scientists are part of society. Of course we are. We are not elitist, but if you're going to regulate what science does, you need to understand it. And I see no evidence that lawmakers do understand it. Now, in that vein, we should read the next one because, and
Yes,
actually, there's only two more, so let's finish them. All
sure.
right. Here's Ian writes. As a fellow virologist, I want to thank you for your steadfast support for the field and your commitment to science communication. As I was listening to the podcast from June 30th and 23, I paid particular attention to your discussion about the House budget bills and public statements about gain of function research. Given my previous positions in government dealt directly with this topic, I hope that you would expand your comments beyond the fact that gain of function is too broad of a term for policy actions and share with your listeners that there is, in fact, a specific definition of research that is considered risky enough for additional oversight. Moreover, there's a revised policy framework that defines, such research and articulates the additional oversight, checks, and balances that would follow. This revised policy was published on May 6th, and he provides a link by the White House Office of Science and Technology Policy, and it directly addresses many of the concerns that the representatives in the House cite as concerns. I do not recall if the podcast ever mentioned this revised policy framework or the fact that the concerns being raised by the House bills and other critics have already been addressed by policymakers. If you have, then great. If not, I would encourage you all to become familiar with the definition and share it as a critical piece of science communication on this topic. Dr. R, I recall being in the room for your past comments to the NSABB on this subject. I believe you'll find the implementation guide that accompanies the revised policy directly speaks to the distinction between experiments that seem scary to non-scientists but are not dangerous and those that should warrant an extra layer of careful consideration by scientists and other experts. For additional context, this policy was drafted with input from the NSABB, feedback from a public request for information, and 2+ years of analysis and policy assessment. The principal authors were PhD virologists and molecular biologists. Best regards, Ian. So, Ian, I'm aware of the revised policy. I think we even discussed it quite a bit of time ago. Let's see when it was published here. May
The
6th.
revised, yeah.
And I
Monthly
think we did
discuss.
because this contains statements like any experiment that is reasonably expected to be dangerous should not be done. You know, that phrase reasonably expected. How can you be reasonably expected anything in science?
There is a tremendous amount of that in law.
Yes, I understand.
The reasonable person standard for everything. Would a reasonable person consider the yada yada yada? And how do you define a reasonable person? Well, it's somebody who is in possession of the facts, presumably. It is possible to, and I probably should have jumped in a little more on this. In the process of formulating legislation, there's a lot that goes into it. So a congressman saying, we're going to ban these gain of function studies. Okay. He is probably clueless. Yeah. I mean, your point is totally valid there that you shouldn't just be going off like that. But he's got a large staff of people who are going to be researching this and reading this, policy from the White House and the definitions of it and crafting an actual legal document that spells out, well, what is gain of function research? And hopefully what comes out of that process is something that is a reasonable level of regulation.
Right. So that was the other thing I was going to say. I was railing against the House document because all they said were going to ban gain of function. Okay.
Yeah.
That's what the public is seeing. That's what the Congress people said. So that doesn't help. If they said we are going to regulate gain of function according to the revised policy issued by the OSTP, great. Fine. Then I would be fine with it. But don't say ban gain of function blanket. Now, this
It
revised
plays better in the ratings.
This,
Yeah.
of course, it's a politically
Yeah.
driven statement because people say gain of function, COVID, Wuhan Institute of Virology. Yeah, let's ban it, right? Ian, we did talk about this document. This is the expanded oversight document, right? Where we now include other organisms that weren't before in this potential pandemic experiments that could make pandemic agents worse and so forth. And a lot of people had issues with the expansion of that because they're going to make doing research more difficult. And it doesn't seem to be any reason to do it, especially since nobody has made ever anything that caused the problem globally, right? So, what kind of problem are we trying to fix? And that's probably what I said at the NSABB meeting. Yet, we have these regulations which are out for a year now. You have to comment them over, right? You have a year before they will probably fall into law. And I appreciate that you point this out. And I will put a link to the TWiV where we discussed this revised policy. But again, in the end, I, just saying we're going
What
to
is
ban
it you're
gain of
trying to
function isn't
this
enough
is
for me, no matter what the underpinnings.
this is another recurring problem in lawmaking that we end up with laws against things that don't actually prevent whatever it was that people perceive to be the triggering
Yeah.
incident. Yeah.
See, the problem is I shouldn't be mingling at all in politics of any kind. I should just stick to the papers and not comment on any of this because I just get riled up. Okay, one more, Alan.
All right, Jeannie writes, "Hi Vincent, thanks for the great podcast, especially the one where you and the crew went point by point and refuted the New York Times terrible article. Here is a poem that isn't right for the podcast, too bad, but I just thought I'd share it. The gaslighter versus the old man up past his bedtime. On the left, a man vigorously telling right-wing lies. On the right, a man unable to make coherent replies. What matters most, truth or clear thinking? As we watched, our hearts were sinking. Only hope is the cloud of witnesses that can sustain a state of witlessness."
Hmm.
Thank you, Jeannie.
Time for some picks of the week. What do you have, Alan?
I have a video. It's about a 30-minute video, but really I'm just picking the first few minutes of it. This guy, Roger Barnes, is a British fellow who goes on sailing cruises, multi-day sailing cruises on a 14-foot boat, a 14-foot sailing dinghy. So he is crazy in the best British tradition. This is just, why would you cruise on such a tiny boat? But he's written a book about it, and he does these videos. And at the beginning of this video, he's becalmed. He's drifting along at maybe a half knot toward the destination, and his philosophy about the situation is just so wonderful that I highly recommend watching the first maybe 3 or 4 minutes of this. The rest of the video is also very entertaining, especially if you're a sailor. Go for it. But just the first few minutes, check out this guy's
Okay.
perspective. It applies to so many things in life.
All right. My pick is a National Geographic video called Billy and Molly, an Otter Love Story. I just stumbled on this the other day. It's just amazing. This guy, Billy, who lives up in Scotland in the middle of nowhere, he finds an otter on his dock one day who's obviously starving, and a young otter probably lost its mother, and begins to feed it and nurse it back to health. And this is the story of this It's just so heartwarming. It's amazing. And the otter, they cover about a year in this relation. The otter eventually becomes pregnant and gives birth to a baby otter, and it's just great. And it's narrated by the guy's wife, who bemoans him paying so much attention to the otter. And she says, he's supposed to be repairing our house. And then at one point he starts working, and she said, "Oh, it looks like Billy has started working on the house again." And he said, "Oh, today he told me it was done." But what he did, in fact, was build a little house for the otter to live in. And he puts a webcam in it, and she goes, "That little otter house has Wi-Fi and we don't in our house." So you can watch the otter's activities. And then later at the end of the film, when the otter has a child, you can see the two of them playing in there. It's all filmed by the National Geographic, so it's beautiful. It's just gorgeous. I don't know how they did this, because they start with the otters half starved eating a piece of crab on the dock, and I don't know how they got all of that. But it's really well done, really well narrated, and yeah, it's so cute. This otter, even though it's the sea, it's not a saltwater otter; it's a freshwater otter, and he realizes that early on. So he makes this little bath for the otter to go with fresh water to swim in every day. And one day he fills it with these little colored plastic balls to amuse. I mean, it's just he brings the otter out and teaches it how to fish. Right? It's just so funny, and it's beautiful.
This I bookmarked this. This sounds
It is
absolutely delightful.
totally great, and shot in the inimitable way of National Geographic. Oh my God, it's so beautiful. So yeah, you got to watch this. Yeah, I think it's like it's an hour and 20 minutes, but oh my gosh,
Yeah.
so good. We have a listener pick from Fernando. Hi, TWiV scholars. I know Vincent is a bit grumpy about all the space picks. No, I'm not grumpy. I'm just like, why are there so many space picks? But here's another one to complement Brienne's Water on Mars story. Kelly and Zach Wienersmith's book, A City on Mars, which digs deeply and very entertainingly, zany drawings included, into the physical, biological, psychological, social, economic, and political challenges of extraterrestrial settlement. Too long, didn't read. Water supply is just a small piece of the puzzle. Thank you for the science, the good advice. No pig or cow hugging, and the fun. Thank you, Fernando. A City on Mars.
Speaking of books that are in my long to read list.
Can we
Yeah.
settle space, or should we settle space, and have we really thought this through? I hope someone has thought it through.
Yeah, well, I am looking forward to getting around to that book.
He'll do it for TWiV 1129. You can find the show notes at microbe.tv/TWiV. Please send us your questions, your comments, your picks of the week, TWiV at microbe.tv. If you like our work, please consider supporting us. Microbe.tv is a 501c3 nonprofit entity, which means your contributions are U.S. federal tax deductible. We depend on you to be able to produce these programs, so please help us out. Microbe.tv/contribute. Alan Dove is at turbidplaque.com, alandove.com. Thank you, Alan.
Thank
I have
you.
to
It's always a
look up the
pleasure.
last time we did one, just the two of us, probably as many years ago.
It's been quite a while.
I'm Vincent
Yeah.
Racaniello. You can find me at microbe.tv. I'd like to thank the American Society for Virology and the American Society for Microbiology for their support of TWiV, Ronald Jenkins for the music, and Jolene for the timestamps. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.